Hello, this is my talk for the IAPCT Conference 2024, and I've titled it The Rhythm of Consciousness. I've been working on understanding consciousness using PCT for several years now, including a review article and book chapter that came out a couple of years ago. And this talk is going to go over that, but focus in on um, the key elements of hello, this is my talk for IAPCT 2024. I've called it Rhythm of Consciousness. It's work I've been doing for a few years now. I'm going to go over the approach to consciousness based on PCT. Then I'm going to hone in on some empirical work that we're doing, and I'd like to use it as a forum to get comments and suggestions and discussions around how to test these constructs. Okay, so just a reminder, this is our classic PCT loop. It's a closed loop. It's a continuous process. It's a process that is intrinsically purposive, whereby the reference signals within a living system, typically, set the standards, the values of the perceptual variables that that agent is controlling. And for any one of us, there may be many different variables that are important to control in our lives, but at any one time, we're going to focus on a small subset of those, such as when we're driving, keeping in the center of a lane, for example, or whether we're walking and staying upright. So we will have sensory inputs coming in from our bodies and brains that are compared against the reference signal. This creates an error to the extent that they deviate, and that drives the actions that through the environment, through the feedback functions or complex environmental functions within our environment, close that gap between our perception and the goal we have for that perception. And in doing so, needs to counteract a whole variety of disturbances in our environment, many of which are either unpredictable or would take too long to compute over the timeframes that we work. And so for this reason, PCT provides a foundational model of behavior. And I think it's important to understand control and behavior in living organisms before we try and understand consciousness. And so part of my approach to consciousness is to remind the reader that we first need to understand how non-conscious behavior works. And an interesting paradox that non-conscious behavior can still be purposive. There's nothing in this loop that requires consciousness, and yet this loop is a purposive loop with a goal. Okay, so that was just showing one control unit. In the living organism, we have hierarchies of these control units that are organized in layers so that complex activities can be achieved and long-term, high-level, more abstract goals can be achieved. These are towards the top of the hierarchy, and a long-term, more global goal, such as to be understood in the presentation, is achieved by setting reference values for perceptions below that, which in turn is achieved by setting reference values from below that, etc. So we have this two-way traffic. That bottom graph on the bottom level on the left is a kind of combination of the input and the output streams that are going on dynamically and continuously in a PCT hierarchy. It's most likely to have a branching shape with less nodes, less systems towards the top, but many more as you go downwards as the organism can sort of balance and weight and prioritize different subordinate goals in order to achieve higher level goals. Again, within this system, there's no obvious reason or role for consciousness. Now we get into something slightly richer. Now, if we look at the perceptual hierarchy in the middle of this diagram, this is this very simplified 11 by 3 matrix for the perceptual hierarchy is a simple representation of that hierarchies of control units that I've just covered with you. The perceptual hierarchy in PCT is a learned process of learning perceptions of ourselves and our worlds that we act to control. According to Bill Powers, right back to the 1960 papers, this perceptual hierarchy develops layer by layer from the bottom upwards, and it has learning signals that are given to it by what are called the intrinsic control systems. In other words, whenever the living agent, the living creature, is out of balance within its basic biological systems, its basic biological and homeostatic needs, those errors drive what's called reorganization, which is a trial and error adjustment of the control units in a perceptual hierarchy. They might get stronger or weaker, there might be changes in delays, etc. Now, obviously, you don't need to change your religion just to learn how to tie your shoelaces. So our brains need some way to focus that reorganization just on one small subset of that hierarchy. Otherwise, we are changing far more than we need to in order to make a difference. And also to focus on one point so you can look at the effects, or you can process, the system can process the effects of a change at a time and evaluate whether to carry on making those changes or not. So that shaded box in that middle column represents the sort of current focal unit for reorganization. And Bill Powers stated again right back in 1960 that that appears to be connected with what we describe as awareness. So awareness follows reorganization, or the locus of reorganization, and what we describe in awareness seem to be one and the same. What I've also added in this diagram is what I've called a propositional system. And you'll see that it's got lines going from the perceptual hierarchy to the propositional system. What this represents is what Bill Powers called order reduction, which is the ability, particularly of humans, to use symbols to represent a whole array of different perceptual variables and different objects and agents in its perceptual world, and then use those symbols in a way that allows them to be manipulated and stored, and things like logic and maths to be applied onto that symbolic system. So arguably, these three systems, an intrinsic biologically derived non-conscious system, a perceptual experiential learned system, and a propositional symbolic logical and hypothetically objective. It's more around facts and figures than it is about personal preferences. In my paper, I propose that these three different systems are essentially operating under different rules and in different arenas. And there is no simple mapping, one-to-one mapping between them, because they can operate independently and they can come to different conclusions. And therefore, we need some overarching mechanism to cut across these three components. And that is seen to be the kind of global workspace, if you like, of the existence of consciousness. Okay, I think I shared with you some examples of intrinsic systems, but let's just say that this is very this area is not worked out in detail. We do not know what the specific intrinsic systems are. We don't know how they're hierarchically related to one another, or indeed how their error signals are combined or prioritized. So that's an area for future research. What we do know is most of them are critical to survival. So rather than being there to build on opportunities and plan for future developments, they seem to be largely around maintaining current optimum states for survival. So again, what is it that we think doesn't need consciousness? We've got all these thousands of inputs converging in the hierarchy. We've got these perceptual variables being controlled, and arguably we've got those variables being learned, within the hierarchy very automatically. And I think this relates to the wider literature on iconic or pattern memory or implicit grammar. And we also know that there can still be disturbances, there can still be things that come out of the blue for that organism that it can still react to using its control systems that would not require consciousness. As long as that intrinsic error is kept within a manageable range, and that there's not what we are going to describe as conflict. Conflict being where either two systems within the two control units within the same system, like two goals within a perceptual hierarchy, become conflicted. Somebody wants to overcome their fears by getting closer to a spider, but they want to stay safe by avoiding it. So the controlled variable of distance is in conflict. But also there can be potential disparities, as we've talked about, between what the intrinsic system wants, what the perceptual system wants, and what the logical propositional system is concluding. And so consciousness, arguably, according to the theory, is manifested when these conflicts appear. As the intrinsic error builds up, reorganization is allowed to prosper, and we get what we describe as awareness. It adjusts those parameters, and then control is restored as normal. If this is the case, then we'd expect that consciousness would just disappear again once the normal automatic processes of control can reinstate themselves. Now, whilst that might be one solution for a living organism, what benefits might there be if that consciousness could sustain? If the organism was able to draw a continuity between the consciousness it achieved to resolve one problem and then to plan for another? What if the system could not only deal with actual threats to its survival, but actually constantly be on the lookout for new variables in its environment to perceive and control? And this arguably is where the model of mind becomes more unique, proposing that there's another intrinsic system, a novelty engine. Now, this kind of system has been intimated, if you look at it across the wider literature, going right back to sensation seeking, stimulus hunger, for example, learning and innovation rates. We're going to propose it within PCT as an intrinsic control system. What is the variable that it controls? The rate at which novel combinations of inputs, chunks from those lower levels, are integrated to specify a novel perceptual variable. So in addition to consciousness having this global workspace, it is also constantly noticing and bringing in a new combination of perceptions coming upwards. It samples those periodically. It has to do it periodically. It can't do it in continuous time because all signals take a period of time from different parts of the brain and the body to get there. So it has to do it on a periodic cycle. And there have to be a certain number of inputs, a quantum number, 1, 2, 3, 4, 5, not a continuous variable, a quantum number of inputs within that period. While that's happening, because we know what reorganization is, we know that there needs to be a focal input, the control variable that is whose unit is going to be reorganized. But at the same time, there's going to have to be awareness of other factors at the fringe, at the edge, the context, other goals, unintended effects that this conscious system has the potential to integrate and develop new heuristics, new rules of thumb as the living creature goes through its environment. And I hope you've seen there that the time and the rhythmic nature of this is key. Okay, so what have we established that that we need? We need to be able to focus on one input for sustained activity and for reorganization. But we also need and want to take in new information, to be naturally curious, take in new combinations to learn more about what we can perceive or maybe how we can resolve problems differently. And on the face of it, having things novel change over time and keeping them the same seem the opposite. Okay, and that's why I've tried to represent in these circles. They don't match up with each other. Which you're going to do? Are you going to focus on one thing, or are you going to create a turnover of experiences? But this is the scenario when there's a bandwidth of 1. It's an either-or situation. However, arguably, what happens when you widen the bandwidth? If you widen the bandwidth, it looks like you might be able to have your cake and eat it. You might be able to feed this novel system that's seeking novelty by giving it a turnover of change of input. But at the same time, one of those bands can be focused on continuity and maintaining an input over time. And so arguably there's this huge advantage that comes from expanding our consciousness bandwidth, which might be what other people have called the global workspace or working memory perceptual load. And what I would argue is that as that bandwidth expands and our control over it expands, and that we become more adept at balancing these 3 fundamental systems, then we're enabled to have this, what is essentially a buffer, way of buffering information coming in so that we don't have to react and control it in the way that we automatically might do, because we have many more options across the system that it can process and evaluate. Okay, this is where the theory is very much in its early stages. I've suggested that when we have a bandwidth, if an organism has a bandwidth of 1, it's very limited. It's got this drive for taking in new input, which means it can't take in new input and sustain its awareness at the same time. However, there is this concept within neurophysiology called delay lines, where new inputs, if there's a very small delay in terms of milliseconds, then they could be sent through longer pathways of neurons so that they converge together at the same time for another neuron. So they actually can then integrate, and you can develop learning from it. But if you only got a bandwidth of 1, you have to rely on those automatic delay lines for integration, arguably, according to theory. But what happens if you've got a bandwidth of 2? It looks like then you can combine 2 inputs in awareness and hold them for a length of time and resolve that issue between sustaining attention and novel integration. And arguably, but then where does the continuity come from? So if you have a bandwidth of 3, you've got 1 band to maintain that continuity of time and the self, and then you've got 2 bands to do some integration and some conflict resolution. So arguably, you need a sort of minimum of 3 bands in order to combine the benefits of consciousness for continuity with the benefits of consciousness for integration. Okay, so that's the theory. How on earth do we measure this? How do we measure focus? How do we measure novel information integration rate? And how do we measure bandwidth? I think in terms of measuring focus, we do have a number of very long established tasks out there. This is one called the Mackworth task, where you just need to follow a dot around the clock face and then just indicate every time it jumps. to do it, you have to keep focusing on that one perceptual input despite its movement. There will be others, but I think we've probably got what we need for this focus assessment on me. In terms of rated novel integration, Mike Landman, my PhD student, has developed two paradigms and is in the process of a third. And Tawzif from Melbourne, who I've worked with for many years, is working on another one. The principle of all of them is that the participant is in control of their input. So they are given an environment, and then we allow them to take in inputs from their environment, a variety of inputs from their environment at a rate that they find satisfactory, that they prefer. And so, for example, within the VR scenario, we have this sphere of multiple colors. That end there is the high information rate, information area. This is the medium information area, sort of halfway through. And then at the other end is a low information area. So we give people access to this VR environment, and we measure that input over time. We're also in the process of looking at a white noise task, where we think that as you look at that white noise for a period of time, the rate at which you start to report shapes and objects is a result of that integration, and that will give an indication. And then the one below here, we've got the fractal Mandelbrot video. And again, what we want to do is find a way to assess people's attempts to control this at a certain rate, even when there are disturbances, even when the computer is trying to speed it up or slow it down. We want the user to maintain a rate that they prefer, and then we're going to take that as our measure of their novel information integration rate. And then thirdly, we had the bandwidth task, and Tawzif and myself and Amy and Mike and Zara and many colleagues have been working on this, including a group of undergraduate students. We started with a task that was monochrome, where the position changed randomly, but we found that people could always find some way to use their iconic automatic memory of patterns and shapes to achieve it. So what we're currently working on is a version where there are different shaped objects that appear in a different random location each time. The majority of them stay the same color, but two of them switch color. So in order to do well on the task, we have to really be able to track and take in the color of each of those different shapes, regardless of their position, and then be able to report on which of the shapes have changed color. We are in the process of doing this. We don't know whether it's going to tap into that bandwidth. It's been hard to measure this because in theory it's a sort of multimodal, multi-sensory space, but we can report on where we're up to with this, and discuss and get questions from you on how that's going. What are the plans? The plans are to combine these novel measures with standardized tests to show construct validity and some convergence of them, assessing the same constructs. We hope to show there's test-retest reliability. But I guess the key is when we can get to the point of formulating what this relationship is between novel information integration rate, sustained awareness, and bandwidth, and then test that model against the participant data, and see that the individual's data corresponds to that mathematical functional relationship between those elements. There will be a big challenge for that, partly because we've broken it down into different tasks, so they might sort of compensate and use different properties depending on the task. There's going to be variation in things like sleep, time of day that all kind of balance out against their natural, the tendency for this novelty system to be operating rather than say a threat system if they're anxious. We're not got to the point of specifying this model numerically, and an even bigger challenge is to bring that time frame into there, which again is over multiple time periods into that specification of the model. But I hope I've still been able to give you an overview of why I've put forward this consciousness model using PCT, and how as a team we are doing our best to develop the paradigms that can allow us to assess it and ultimately get a more robust model of consciousness. I hope, again, I didn't spell this out as I go across, but you can see the practical and the clinical implications of things like bandwidth and sustained awareness and novelty seeking. If we can understand how those three come together during child development, during education, during clinical episodes, during challenging situations in the workplace, I think this will really come into its own. So thank you for listening, and I look forward to hearing from you shortly.